If you're taking Calculus 1, you're going to be talking a lot about derivatives, and honestly, they're not as complicated as you think. Let me explain. Derivatives talk about the instantaneous rate of change of a function at any given point. If you recall talking about rate of change, you probably think back to your first algebra class when you're talking about the slope formula and y equals x. The slope formula is m equals y2 minus y1 over x2 minus x1. However, this only works for linear functions. But we want to find the rate of change for functions that aren't linear. So here we have the function f of x. And as we can see, it's clearly not linear. However, we're going to use the same idea of linear functions to get the instantaneous rate of change. Let's start by taking two lines and drawing a linear line through it. Now we don't know the coordinates for these points, but we want to generalize it so we can use it for any given function. So for the first point, let's call the input x. This will make the output f of x. Now the second point is some distance h to the right. We don't know how far it is, but it's some distance h. This will make the input x plus h. And this will make the output of the second point f of x plus h. Now, the original slope formula for a linear line will now be transformed into m equals f of x plus h minus f of x over x plus h minus x. And as we can see, our x's will cancel out. And so we're left with f of x plus h minus f of x over h. However, this only gives us the average rate of change, or the secant line, and we want to find the instantaneous rate of change at a given point. So what we can do is, we can take the limit as h approaches 0. This will make it so these 2 points will get as close together as possible before actually touching, and this essentially makes it so they become one singular point. And so when we do this, it will give us the tangent line, or the instantaneous rate of change. And here we have essentially found the derivative. Let's try some examples now, however. Our first example is we have the function f of x is equal to 5, and we want to find f prime of x. This is the same thing as saying, let's find the derivative of our function. It's just a different notation. Let's start by recalling the formula for the derivative. So f prime of x is going to equal the limit as h approaches 0 of f of x plus h minus f of x all over h. And our function here is f of x equals 5. And so what we'll notice is that our function has no x. It has 0 x's. And we want to take the input of x. So we actually have nothing to input. So it's going to equal the limit as h approaches 0 of 5 minus 5 over h, which will equal the limit as h approaches 0 of 0 over h, which is just 0. For our next example, we have the function f of x equals 2x squared minus 5x plus 1. And let's find f prime of 2. Now we have the function f of x equals 2x squared minus 5x plus 1, and we're asked to evaluate f prime of 2. So let's recall the formula for the derivative. F prime of x will equal the limit as h approaches 0 of f of x plus h minus f of x over h. So now let's substitute for our function. I'm going to write it like this so I have more space. Is equal to the limit as h approaches 0 of 2x plus h squared minus 5x plus h plus 1 minus 2x squared minus 5x plus 1. And this is all over h. Now let's start expanding our terms. So it's going to be the limit as x approaches 0, as h approaches 0. This is going to be even longer. Of 2 times, this is a perfect square, so the formula will be x squared plus 2xh plus h squared minus 5x minus 5h plus 1 minus 2x squared plus 5x minus 1. And immediately we'll notice some things cancel out. This will cancel out, and this will cancel out. The ones will cancel out. I'm sorry, this was all over h. And so now we're left with the limit as h approaches 0. And I'm also going to expand the 2 of 2x squared plus 4xh plus 2h squared minus 5h minus 2x squared all over h. And now our 2x squareds are going to cancel out. And so we're left with the limit as h approaches 0 of 4xh plus 2h squared minus 5h all over h. And what we can notice is that we can factor out an h. So this will be equal to the limit as h approaches 0 of h times 4x plus 2h minus 5 all over h. And I'm going to write this over here. And as we'll notice, the h's will cancel out. So we're left with the limit as h approaches 0 of 4x plus 2h minus 5. And now we can evaluate h at 0, which will be equal to 4x plus 2 times 0 minus 5. And this will just be equal to 4x minus 5. And I'm going to do this up here. We were asked to evaluate f prime of 2. And we just found f prime of x to be equal 4x minus 5. Therefore, f prime of 2 will be equal to 4 times 2 minus 5. And this will be equal to 8 minus 5, or 3. And that is our final answer. Now, let's try something a little bit different. We have f of x equals the square root of x, and we're asked to find f prime of 4. So now we're asked to find f prime of 4, where f of x is equal to the square root of x. Again, let's start by writing down the formula for the derivative, which is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And so let's substitute in our function. And so this will be equal to the limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. And so here we have 2 square roots over the numerator and a minus symbol. And so it's a good idea to multiply the top and the bottom by the conjugate of the numerator. And so the conjugate of the numerator is going to be the square root of x plus h minus the square root of x, and we're going to multiply it by the square root of x plus h plus the square root of x. And we can't change the fraction, so we also have to multiply the denominator by the square root of x plus h plus the square root of x. And so let's leave the denominator as it is, but let's expand the numerator. And so this is going to be equal to the limit as h approaches 0 of, and remember this is a difference of squares, so we have x plus h minus x over h times the square root of x plus h plus the square root of x. And as we can see on our numerator, the x's will cancel out. And so we're left with the limit as h approaches 0 of h over h times the square root of x plus h plus the square root of x. And as we can also see, the h's will cancel out. And so what we're left with is the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. And here we can now evaluate the limit at 0. So it will be equal to 1 over the square root of x plus 0 plus the square root of x, which is just equal to 1 over the square root of x plus the square root of x, which is just equal to 1 over 2 times the square root of x. And here we're asked to evaluate f prime of 4, which is just going to be equal to 1 over 2 times the square root of 4, which is equal to 1 over 4. And that is our final answer. For our final example, we have f of x equals 1 over x, and we're asked to find f prime of 1. For our final example, let's start by writing down the definition of a derivative, which is equal to the limit as h approaches 0, of f of x plus h minus f of x all over h. And let's substitute our function. So it's going to be equal to the limit as h approaches 0 of 1 over x plus h minus 1 over x all over h. And on our numerator, we have two fractions that would probably be best if we subtracted them. So here we have to get a common denominator. Our common denominator is just going to be the product of the two denominators. So it's going to be x times x plus h. So we have the limit as h approaches 0 of, and remember we have to multiply the top and the bottom, so x over x times x plus h minus x plus h over x times x plus h, and this is all over h. Now we can actually subtract our two fractions, and so we have the limit as h approaches 0 of x minus x plus h over x times x plus h over h. And what we'll notice is that our two x's will cancel out, and what we're left with is the limit as h approaches 0 of h over, oh, I actually made a mistake. I just realized. I forgot to distribute the negative properly. Sorry, so let's go back a few steps. When we subtracted this fraction, it will be equal to the limit as h approaches 0 of x minus h all over x times x plus h, and this is all over h. Let's move it over here. And so now, again, our x's will cancel out, and we're left with the limit as h approaches 0 of negative h over x times x plus h all over h. And we have two very weird fractions, so let's turn this into something nice, like a multiplication statement, which will just be the limit as h approaches 0 of negative h over x times x plus h times 1 over h. And as we can see, our h's will cancel out. And so we're left with the limit as h approaches 0 of negative 1 over x times x plus h. And here we can now evaluate the limit at h approaches 0. And so we're left with negative 1 over x times x plus 0, which is just equal to negative 1 negative 1 over x squared. And we're asked to evaluate it f prime of 1, which is just going to be equal to negative 1, which is just going to be equal to negative 1 over 1 squared, which is just equal to negative 1. And that is our final answer.